All right, so we're going to go over a couple of the questions for this one as well. So for number 7, I'm not going to go over 1 through 6, but number 7, first off, it says reduce the size. So obviously we're going to be drawing this a little bit smaller, and it says a scale factor 4 to 1. So that means the bigger one, this first image, since we're making it smaller, is going to be 4 times larger than the smaller image. So if I'm going to make this smaller, each of these sides I need to divide by 4. So this side has a side length of, if you count it, 1, 2, 3, 4. So then that means when I reduce it by that scale factor 4, that means it has to have a side of 1. So it's just going to be a 1 there. So since I see that these are the same on both, I know that the other one across them it's going to be 1, but I'm going to draw that after. Here it's 1, 2, 3, 4, 5, 6, 7, 8. So this base is 8. And since we know we're making it smaller and it's a scale factor 4, I do 8 divided by 4. So it means it's going to be 2 units though. This other side is going to go up 1. And then for this next one here, we see that it is 1, 2, 3, 4. Now, yeah, we're not counting horizontal or vertical, but we're still 4 diagonals. So that means we would do 4 divided by 4. So that means we only need to go through 1 diagonal. And if you count the other way, 1, 2, 3, 4, it's going to be 1 diagonal going the other way as well. So even though we're not counting the true distance, we're still keeping it consistent where we're reducing each side length by that 4. Now you can do this in other ways, but this is just the easiest way for it. For question number 8, it says enlarge it. So that means that we know that we're making it bigger. So by a scale factor of 1 to 5, that means we're making it 5 times larger. So when we solve for this, how big each side is, we will multiply it by 5 to figure out what the size of the bigger one will be. So this side is 1, 2. Well, 2 times 5 is 10. So I know it's going to be 10 units now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again, I know this other side will be 10 as well, but I'm going to wait to draw that one. So this here is 1 diagonal. So 1 times 5 is 5. So it's going to be 5 diagonals. 1, 2, 3, 4, 5. This is the same exact on the other way. So 1, 2, 3, 4, 5. We already figured out that this is going to be 10 up. So I know it's going to be there. And then from here, it's 1. So 1 times 5 is also 5. So I know it's going to be 1, 2, 3, 4, 5. And then it's the same exact image going back. So I know that needs to be 5 as well. 1, 2, 3, 4, 5. So that will be making it 5 times larger. So it's saying enlarge, so we know we're getting bigger. So it's going to be 5 times bigger. For this one here, it says find the scale factor from A to B. So what we're going to do then is just pick a point on A. I'm going to pick this one here, and I'm going to write its coordinates. So the coordinates there for X is at 0, and Y I would say is about 1.5. Now from coordinate B, I'm going to pick the exact same part of that enlargement, and I'm going to write down its coordinates. So its X is 0, and its Y is 2. So since we're going from A to B, and I look, A is smaller, so I know that it is getting bigger. So the scale factor now must be greater than 1, because otherwise that will be getting smaller. So even if I didn't know how to properly do this, I'm creating a fraction or a ratio that's going to be bigger than 1. So since 2 is greater than 1.5, I'm going to do 2 over 1.5, because that's the ratio. And then when you put this in your calculator, or if you simplify this, it gives you a fraction or a ratio of 4 to 3. So that means that the scale factor is 4 to 3. So every single point that we have here, we can multiply it by 4/3, and it will give us the answer. And if we chose a point like this B here that had another X value, regardless if we did the ratio of Y over X or X over, Y2 over Y1, or X2 over X1, it would still give us the same ratio because everything needs to grow at the same rate. But since these are both 0, we can't use those, and we would just use that Y. All right, so from here, we're going from A to B. Well, I see A is getting smaller. So when I do this, I need to think about what numbers I'm going to use that will make it smaller. I'm just going to pick this point here. So it's negative 1, 2, 3. So our X value is negative 3, and our Y value is positive 3. I'm going to pick this point since it corresponds with that point B, and that is negative 1 and 1. And this is what I mean now that we have values for each of them. I know it's getting smaller, so I need to make sure that my ratio is going smaller. So since 1's less than 3, the ratio will be 1/3. And even if I use my x values, it'll be -1 over -3, which is also 1/3. So you see, no matter which one you test or use, it's going to give you the same answer every single time. You don't need to do it for both. If you want to check to make sure it's giving you the same number or scale factor, you can, but just doing it one will give us the information we need. All right, so for this one, number 11, it's giving us a scale factor, and it's now saying what would the new coordinates be. So remember, when you're doing this, you must write it as E prime, F prime, G prime, and H prime. So if for the other way, we divided our numbers to get our scale factor, well, think about what we would do then if we have our scale factor and trying to come up with the new numbers. What we just do is just multiply every single coordinate by that. So when we multiply E, we will multiply the X and the Y both by it. So it's -6 times 5 over 6. Which then will give us -5. So after the scale factor of 5, 6, our x value is now -5. For the y value, it's 2 times 5, 6, which is now going to give us 5/3. So that will be our x and y value for E. When I go to do F, I can now do -3 times 5, 6, which is then going to give me the value of -5/2. And then I would do 6 times 5, 6, which is going to give me +6. For G, we will do -4 times 5, 6, which is then going to give me -10/3. And then we will do 0 times 5, 6, which is still 0. So that will remain 0 there. And then the last one for H, we will do 6 times 5/6, which is the same for both of them. So for H prime, it will just be 5, 5. So when we know our scale factor and our original points, we know then that would have to be just multiplying to figure out the new ones. All right, so for these ones, this would be more of exceeding. But when we're looking at this, if it was just going to be reflected, remember, when it's reflected, it's like the mirror image. When I hold up my right hand, it looks like it's left in the mirror. So if you look at this original one, G is on the left and H is on the right. But when we look at the image afterwards, we see then that they change the spot that they're in. So H is here and G is there. So it's not just reflected because otherwise they would have to be like on the opposite side of each other. So that's telling me that this is being rotated, because when we rotate, that's where it's more about our perception, the way we look at it. Here, if I'm standing here and I'm looking, well, H is on my right-hand side, G is on my left. And as it's rotated around me, H is on my right-hand side, G is on my left. So I know it's being rotated, but since it's not just like a clear spot where it's being rotated like 270 degrees around one point, it also then means it had to be moved. But since it didn't change its orientation of where H and G were at, we know it's not being reflected. So we know we can cross out B and C. So it was rotated and then translated. Whereas if you look at this one, when first we see if that this image is being rotated, because it's just being swung around and that T is still being like at the top. So here we would have, if I were to swing this black one, it would look like this. If we're looking at it, it would be T, S is on this side, U is on this side, V and W. But when we look at the actual image, it's very close to it, but U is on the opposite side. So you see U is here and S is here, and V is here and W is here. So it is being rotated because otherwise it wouldn't be able to be in that exact spot that is. But then if you look, everything's just on the opposite side of what the original image was. So that means it was being reflected. So it's being rotated, then reflected. And that would be the answer for that last one.